Okay, welcome to this video where we'll be having a look at another practice paper for the Paper 3 Foundation Tier exam. This is a calculator paper, and as always, this is just a practice paper. There are lots of topics that haven't appeared, so it was really difficult this year to fit everything into one paper. So this is a second variation covering some other topics that weren't in the first version of this paper, but of course do make sure that you check out both, check out the checklist with all the topics that haven't come up, and obviously bear in mind that some of the topics that have appeared can still reappear. So there's lots of topics to work through. I try and link them all in the description, and just make sure that you check out all of those previous videos and all of the other bits of revision that you should be looking at towards your exam. But here's another practice paper, and hopefully this will be helpful, just covering a few more of these topics that haven't yet appeared. As always, there will be a QR code on the front of this booklet that you can scan to get back to the video, but we're going to get started as we have a lot of questions to get through. So it says here, write down the number 81,079 in figures. So we want 81,000 and then we just want the 79 at the end. And there we go, 81,079. We've got some order of operations here. We have to follow those order of operations in which we do multiplication before we do the subtraction. So we have here 12, take away 6, and we get the answer 6. Writing down numbers in order of size, we want all of the decimal places to have the same amount of decimals. So I tend to add zeros at the end. You don't need to, you might be able to see them without this. But if we add zeros at the end, it does make them a little bit clearer. So this one here, although it's not 30, kind of looks a little bit like 30. So 0.03 is the smallest. Then we have 300, 302 and 320. So of course we're going to write the originals in, 0.3, 0.302, and then 0.32. And there we go, there's our decimals in order of size. The next question asks us to draw a radius of the circle. A radius goes from the centre to any point on the circumference using a nice straight line, of course using a ruler and a pencil for that. Our next question says a fair ordinary dice is thrown once. Write down the probability it lands on a 5. A fair ordinary dice has 6 numbers. A 5 is one of them, so it's 1 out of 6. The next question is looking at coordinates. It says write down the coordinates of point A. So we want to read the x coordinate first. So trace down, make sure that you get that x coordinate first. That has a coordinate of 2, and then the y coordinate there is 3. So the coordinate for A is 2, 3. Then it asks us to write down the coordinates of B. B has an x-coordinate of 0, as it's just there on the y-axis, but it's down at -1. So that's 0, -1. And there we go, there's our coordinates of B. It says on the grid, mark with a cross the point -2, 1, and label it point C. So -2 is along the x-axis, over to here, and then up to 1, so we'll mark that with a cross, and we're going to label it C, like we've been asked. So there we go, that was looking at some coordinates. It says here Liam is choosing an outfit. He can choose one shirt and one pair of trousers from his wardrobe, and then it gives us the options. It says write down all the possible combinations that Liam can choose. So what we're going to do is we're going to pick the first shirt and match that up with each of the 3 types of trousers. So we can write the first letter, so R for red and J for jeans. R for red, S for shorts, R for red, C for chinos. Now what we're going to do is do exactly the same thing, but instead of going for red, we'll now go for blue, match it up to all 3, and just write all these combinations down. So B for blue, J for jeans, B for blue, S for shorts, B for blue, C for chinos, and onto the last one for green, and J for jeans, green and S, green and C. And there we go, there's all of our possible combinations that Liam can choose. Sophie is buying stationery. She needs to buy 4 marker pens at £1.25 each, 3/4 of a kilogram of glue at £2.80 per kilogram. Sophie has £7. Does Sophie have enough money? And you must show how you get your answer. Well, if she buys 4 marker pens and they are £1.25 each, on our calculator we can do £4, or 4 times £1.25. We want to write that working out down, even though we've typed it in the calculator, and that is going to give us £5. So that's how much she spends on marker pens. The other bit of information we have is that she's going to buy 3/4 of a kilogram of glue, but it's £2.80 per kilogram. So we need to work out 3/4 of £2.80. We would start by working out 1/4. So we'll do £2.80 on the calculator, divide by 4, and that gives us 70p. So that's 0.70, and we want 3/4, so we're going to times that by 3, again on the calculator, and that comes out as £2.10. I'm just going to write here that I've times that by 3, and the overall cost is adding them together, which again I'm going to show 5 plus £2.10 is equal to £7.10. So does Sophie have enough money? I would want to write a conclusion. No, Sophie does not. And it's backed up by nice, clear, working out, really clearly shown. And there we go. There is our answer for that one. Question 9 is looking at a bar chart. Now part of this bar chart has already been drawn. It says the bar chart shows information about the number of hours of sunshine above 25 degrees Celsius each month for 4 months in a city. It then says in May, the number of hours of sunshine above 25 degrees Celsius was 25 hours. In June, it was 35 hours. Use this information to complete the bar chart. So obviously read the scale carefully. We have May is 25, so we'd want to use a ruler and a pencil to construct some nice, clear, straight lines here to draw our bars in. And that's up to 25. Again, just trace your ruler along, make sure that's definitely on the 25. And then we'll do exactly the same for the 35 for that month of June. And again, nice, clear, straight bars as we draw these using a ruler and a pencil. And there we go, there is our bar chart completed. It says Ravi says in February there were 15.5 hours of sunshine above 25 degrees Celsius because the bar is half a square above 15. Explain why Ravi is incorrect. Well, let's have a look in February. So in February here, the bar is in between these two numbers. However, between those two numbers, it goes from 15 to 20. So the middle of that would be the middle of 15 and 20, which is 17.5. The midpoint there is 17.5. So we would want to say that although Ravi is correct that it's halfway between the bar, actually that would relate to 17.5 as it's halfway between 15 and 20. Any variation of that language would be fine, so we won't write an answer down for this one because you could phrase this in lots of different ways, but the important part there is it's the midpoint of 15 and 20. Okay, so our next question is looking at sequences. This is the nth term of a sequence is 4n minus 5. Explain why 30 is not a term in the sequence. Now there are two ways that you could do this. We could either guess some numbers and see if we get close to 30, or you can solve it as an equation. Now the equation method is a little bit more advanced, but if we do 4n minus 5 equals 30, and we try and solve that, when we add 5, we get 4n is equal to 35, and then when you do 35 divided by 4 on the calculator, you don't get a whole number, you get n is equal to 8.75. So we could say n is not a whole number, that's one variation, but there is another way that you could solve this as well. Now we've seen there that it's 8.75, which means it's somewhere in between 8 and 9. Let's just imagine that we guessed that it was n equals 8 to start with. We would do 4 times 8 minus 5, and again we'll type this in on the calculator, and that gives us 27, which is below 30, and then we would have maybe guessed n equals 9, so 4 times 9, take away 5, again we can just type this in on the calculator, and that gives us 31. And we could write something along the lines there that therefore it must be between 8 and 9 because it doesn't actually hit 30. So two different ways that you could solve a question like that using an nth term. Part B says here are the first 3 terms of a different sequence. Write down 2 numbers that could be the 4th and 5th term of this sequence and give the rule that you've used to get your numbers. Now if we look at this sequence, it goes up by 2 and then it goes up by 3. So to get the next term, we could go up by 4 and then up by 5. Now that would give us 11 and it would give us 16. So they could be the 2 numbers there, so the rule that we would give would be adding 1 to each difference. Goes up by 2, then 3, then 4, then 5. And of course you could write lots of explanations next to that, but just making it very, very clear exactly how you've done that. Now it's not the only variation that you could do. You could also have 2, 4, 7, so it goes up by 2, up by 3. We could also just repeat that pattern, so up by 2, up by 3. That's another variation of one that you could do, so 9 would be going up by 2, and then going up by 3 would be 12. And again, I would say in that one, it's a repeating pattern of going up by 2 and up by 3. Again, it does say give the rule you've used, so you'd want to write the description based on whichever one you use there, but either one of those would be fine. Question 11, it says here is a prism. How many faces does the prism have? So the faces are these flat surfaces. So that there that I'm highlighting is one surface of the prism. So we want to count and see how many there are. There's one on the front, there's one on the back, and then there's 1, 2, 3, 4, 5 around the outside. So 5, 6, 7 in total. It then says how many edges does the prism have? Well, when we're looking at the edges of the prism, we're looking at those nice flat lines, and I will highlight one of them. There's quite a lot of edges, but this line here is one edge. So this face on the front has 5 edges, as it is a pentagon. On the back, it also has 5 edges. We then just need to count all these ones that are going around the outside. We have 1 here, 2, 3, 4, 5. So 5 on the front, 5 on the back, and 5 around the outside. That gives us 15 in total. So the prism had 15 edges. Okay, question 12. It says Arena uses her van to deliver garden furniture. You can use this graph to find the delivery cost for different distances. And we are given the graph and we have a starting number up here. It says for each delivery, there is a fixed base fee plus a charge based on the distance travelled. How much is the fixed base fee? So that fixed fee is this starting amount right here before the van has even left. Now that's exactly halfway between 0 and 20, so that is £10. So there we go, our final answer for that one, £10. It says Arena makes 2 deliveries. The distance of one delivery is 20 miles longer than the distance of the other. Work out the difference between the 2 delivery costs. So we want to find 2 points, ideally, if we can, nice whole numbers, where the distance between them is 20 miles. Now the first point that I can see, which looks relatively nice, is this one here at 20 miles, and that is £40. So if I can find one 20 miles ahead, so let's go up from 40, and we'll read that number very carefully. Hopefully it lands on a whole number. Let's have a look. There we go. Trace along. And it lands on 70, perfectly there between the 60 and the 80. So the difference in cost from 40 to 60, well, we can do 70 take away 40, and that's a difference in cost of £30. So there we go. We can obviously write down 70 minus 40, down now working out. We've shown it really clearly on the graph how we've got those numbers, and our answer is £30. Okay, so there we go. Using a conversion graph, but a sort of real life delivery cost version here with that fixed charge at the start. Okay, so looking at some inequalities, and we have an equal sign in this one as it asks us to use a symbol from the box to make these statements correct. Now the first one, it says 3/8 and 37.5%. Now on our calculator, if we type in 3 over 8 and click equals, we get the decimal 0.375. To turn that into a percentage, times by 100, and it is 37.5%. So 3 over 8 is actually equal to 37.5%. The next one, we've got some negative numbers. -9 take away 4 is -13, and -3 times 4 is -12. And again, you can use your calculator for that. Now, -13 is smaller than -12, so we would use our less than symbol, as -13 is less than -12. So there we go, just using the calculator, just to double check on those, and then putting the appropriate symbol in. Question 14, we have some substitution. It says t is equal to 3a plus 4b. 3a means 3 times a, and a is 5. So we have 3 times 5, and we're going to add to that 4 lots of b, 4 times -3. Now you can type these bits into your calculator individually if you prefer, just to tidy this up. 3 times 5 is 15, 4 times -3 is -12, and we're going to add that to 15. You can type that in on your calculator, 15 add -12, and that comes out as 3. So there we go, the value of t is equal to 3. Part B, it says to factorise fully 6x squared plus 9x. It has this word fully here because there's a number and there's a letter that can be factorised out of this. Now looking at the pieces, they both divide by 3 and they both have an x in. So I can put 3x on the outside of the bracket. I just have to think to myself, how do we get back to 6x squared? I've got to times by 2 to create the 6, and I've also got to put an x in to make sure we get the x squared. I need to keep the symbol the same, and then how do we get to 9x? Well, that's just timesing by 3. I don't need to put another x in there as it's not an x squared that I'm trying to get to. And there we go, we have fully factorised that expression. And there we go, writing that nice and clearly on my dotted line. Okay, question 15. It says 15 metres of fabric cost £10.75, 8 metres of fabric and 4 metres of ribbon cost £21. Sammy buys 3 metres of fabric and 2 metres of ribbon. He pays with a £20 note. Sammy thinks he'll get more than £11 change. Is Sammy correct? You must show how you get your answer. Now this kind of statement here, the first line we can actually work something out from. We can't in the second because this is about 2 different things and we don't know the cost of one of them yet. But the first one, we can do the 5 metres of ribbon, which is £10.75, and divide that by 5. We can type that in on the calculator, £10.75 divided by 5, and that equals £2.15. So that is the cost of 1 metre of ribbon, or 1 metre of fabric. We now need to work out the cost of 1 metre of the ribbon. So this second statement tells us that 8 metres of fabric, which we now know is £2.15 per metre, so we can do 8 times £2.15. Again, we can do that on the calculator. It comes out as £17.20. And then we also have 4 metres of ribbon, let's call it 4R, and that's equal to £21. Well, to work out the cost of the 4 metres of ribbon, we want to subtract the £17.20 from the £21, and we'll know what the 4 metres of ribbon costs. So 21 take away £17.20, and that comes out as £3.80. Just like before, we now know the cost of one of these things, so we can divide this by 4, which will tell us the cost of 1 metre of ribbon, and we'll call it 1R, and £3.80 divided by 4 is equal to 95 pence. So now we know the cost of the ribbon and the cost of the fabric. Again, it'd be worth just underlining those because we've got a lot of numbers written all over this question. We want to know which ones we want to look back at. So here, Sammy buys 3 metres of fabric, 2 metres of ribbon, and then he pays with a £20 note. So let's work that out. So 3 times £2.15 for the fabric, and 2 times the 0.95. We can type that into the calculator in one go, plus 2 times 0.95, and that gives us a total cost of £8.35. So that's the total cost of the 3 metres of fabric and 2 metres of ribbon. It says Sammy thinks he'll get more than £11 change when he pays with the £20 note. Is he correct? Well, 20 take away £8.35. 20 minus £8.35 comes out as £11.65. So Sammy thinks he'll get more than £11 change. Is he correct? Yes. Okay, he gets £11.65 change. So there we go, they are correct, and there's our final answer. So there you go, just a question there, working with money, and one of those variations where we had to start with that one statement at the start to get the value of the fabric. But there we go, working with some money. Okay, so here we're looking at a reflection, and it says describe the transformation that maps shape A to shape B. Now it's obviously a reflection as the shape has not moved, it has actually changed that, it's flipped over. We've got to use the word reflection, but it has actually moved in terms of that position. It's not just rotated, it's not enlarged. So we say that this is a reflection, we just have to say the line that it's been reflected in. So we say the word reflection in the line, and then we want to find that reflection line. In this particular one, the reflection line is the x-axis. There are 2 ways to describe that. We can call it the x-axis, or we can call it y equals 0. Now, it's not normally one that I would name as y equals 0 because it does have that name of the x-axis. So when we're writing the description down, in the line, I would say y equals 0, or I would say in the, and then just write the x-axis. And there we go, so it's a reflection in the x-axis. The next question tells us that there are two parallelograms on a coordinate grid, and it says parallelogram D is a reflection of parallelogram C. On the grid, draw the mirror line. Now this one here is one of those diagonal lines. You've got to be very careful, but it goes through all these points, 1, 1, 2, 2, 3, 3, and so on, and it creates this nice diagonal line. You just need to be very, very careful. Don't assume that the grid has the same numbers here. It doesn't always just attach to this top corner. So just watch out very carefully that you do mark a few points on when drawing one of these lines. It says write down the equation of this mirror line. Now this particular one, which is sloping upwards in this positive quadrant here, is called y is equal to x. You do also have another variation. We don't have it in the negative quadrant here, but if it's sloping downwards, this diagonal line, we'd also have the variation of y is equal to negative x. But this particular one was y is equal to x. This next question says here is a trapezium. The area of the trapezium is 91 centimetres squared. Work out the height of the trapezium. Now you are given the formula for the area of a trapezium. It's half a plus b and then multiplied by the height. Now that's how it's written. We just need to apply this to this question, and 91 is the area. That's equal to half 10 plus 16. And then I'm going to put times the height here because we can actually work out this middle piece. A half times 10 plus 16, or 10 plus 16 on the calculator is 26. A half of 26 is 13, so we have 91 is equal to 13 times the height. And we can just divide by 13 to figure out what that missing height is. 91 divided by 13 is equal to 7. So we get h, or the height, is equal to 7. So 7 centimetres is our final answer, and that's just reversing there the formula for the area of a trapezium. Our next question is looking at some exchange rates. It says at Tech Zone UK, the price of a smartwatch is £64.50, and at Gadget World USA, the price of the same smartwatch is $85. It gives us the exchange rate, £1 is equal to $1.35. The smartwatch is cheaper at Gadget World USA than at Tech Zone UK. How much cheaper? Now you can convert this into either currency, but the question here does say to give your answer in pounds. So it makes sense for us to take the $85 and convert that into pounds. To do that, the pound number is smaller than the dollar number, so we're going to have to divide by this exchange rate. So divide by 1.35. Just double check, we should know logically here that we do get a smaller number, and that number comes out as £62 and then 962. Now of course we're going to round this to the nearest penny, so that's going to be £62 and 96. So if we have £64.50 for the Tech Zone UK smartwatch, we're going to take away the £62 and 96 pence for the Gadget World UK, and we do that on the calculator. £64.50, take away £62 and 96 pence, and that comes out as £1.54, and that's £1.54 cheaper. Now in a question like this, technically we could potentially round that to £62.97, even though it's closer to 96 pence, as it does cost over 96 pence, so technically it could be rounded up to 97, so we could have a 1 penny sort of variation in our answer here, but this answer is absolutely fine. I would just stick to the rules of rounding on this type of question, so £1.54 is the difference in cost there. It's £1.54 cheaper. Okay, question 19. It says Leela is going to buy 12 cans of paint. Here is some information about the cost of paint from each of the two stores. Leela wants to buy the 12 cans of paint as cheaply as possible. Should Leela buy the paint from Brush and Roll or from Paint Plus? And you must show how you get your answer. Well, she's going to buy from one or the other. So here, if she buys from Brush and Roll, in order to get 12 cans, she's going to have to buy 3 lots of the pack of 4 cans. So 48 times 3, we'll write that down here, 48 times 3, that's equal to £144. So that's how much it's going to cost her if she buys from Brush and Roll. From Paint Plus, there is a 15% discount on the normal price. So we've got two options. We could either work out the 15% discount on the pack of 6 and then times it by 2 to get to 12, or we can times it by 2 and then work out the 15%. Completely up to you. I'm going to do 2 times 84, work out what it is without the discount first. 84 times 2 comes out as £168, and then we need to get the 15% discount. Now there's two ways to work out a 15% discount. We can either work out 15% using any method that you prefer and then subtract it from 168, or you can use a multiplier and we can work out 85% of the cost, and then that will give us our answer straight away. I do quite like using a multiplier. If we reduce by 15%, 100 minus 15 leaves us with 85%, and 85% as a multiplier is equal to 0.85. So I can do 168 multiplied by 0.85, and that is equal to £142.80. So £142.80 has put it just below the cost from Brush and Roll, so Paint Plus is where we should buy it from to get the cheapest offer. So should Leela buy the paint from Brush and Roll or from Paint Plus, she should buy it from Paint Plus. And ideally, write a full sentence there, just say Leela should buy the paint from Paint Plus. And there we go, there was looking at a best buy with a percentage discount. Now question 20 is using a calculator. So with this, we just want to make sure that what's written on the page looks exactly the same as what we write on the calculator. Now you can work out the top first. If you don't have a calculator that has the sort of dual level where you can write on the top and the bottom of a fraction, you can work out the top first, work out the bottom, and then divide them. But here we just want to make sure it looks exactly the same. If you've got a calculator to practice with, for this one you should get 157.668,255. And it says in part B to round your answer in part A to 4 significant figures. The fourth significant figure is the fourth after the first whole number, so 1, 2, 3, 4. In this case it's in the first decimal place, after the 6 is another 6, so it rounds up to 157.7. And there we go, there's rounding to 4 significant figures. Question 21 is looking at expanding 2 sets of single brackets. So here we want to expand the first bracket to start with. 3 times m is 3m, and 3 times 5 is 15. Now you have two options in the way that you expand the second bracket. Because there's a subtract in the middle, we do need to be very, very careful with this one. We can either expand the right bracket by 5 and then we have to take them both away, or we can just use this as a -5 and times by -5, which should be fine because you also have a calculator. -5 times 1 is -5, and this is normally the piece here where people will make a mistake here, as it's -5 times -3m. -5 times -3 is positive 15, so it's positive 15m. So be very careful there, because if you did times by just 5, you'd get -15m, but then we're taking away -15m, which does mean it turns into a plus. From here, we would just collect like terms, so 3m add 15m in total gives us 18m, and 15 take away 5 in total gives us plus 10. So our final answer there is 18m plus 10. And just go back, double check your symbols, make sure you're happy with it. I'm happy with that. So 18m plus 10 as my final answer. For question 22, it says Liam buys a box of 20 chocolate bars. The box costs £9.80. He sells each chocolate bar for 65p. Work out Liam's percentage profit and give your answer to 1 decimal place. So here we want to know the actual profit he made. So he got 20 chocolate bars, he paid £9.80, but he sold them for 65p. So we can work out 20 times 65. You could either work it out in pence, or we could write that as 0.65, which will write it straight away in pounds, and that is £13. So he sold them for £13. Now he bought them for £9.80. So the profit that he made is 13 take away £9.80. And if we do that on the calculator, that gives us a total profit of £3.20. Now, if we want to work out the profit as a percentage, we would write it exactly like we would write a test score. If you scored 13 out of 20 on a test, you write it as 13 out of 20 and times it by 100 to write it as a percentage. So here we got £3.20 profit out of the £9.80 that we paid. So it's the change or the profit over the original amount, and then we just times that by 100. So £3.20 on the top, £9.80 on the bottom, all on the calculator, times 100, and that comes out as 32.65306. There's a lot of decimals here, so I am going to stop because it only wants it to one decimal place. So we take it after the 6 here, and that comes out as 32.7%. So there we go, we've already got that percentage symbol there, so it's just 32.7, and there's the profit to one decimal place. Question 23 is looking at some fractions. A quite unique one, as it says, show that 2 5/8 divided by 1 1/6 is less than 2 1/2. Now there are parts to this that you can use in the calculator, but it does say show that. So we need to show all of our working out. So the first part of showing it would be to show how these can be written as improper fractions. So 2 times 8, and there are bits you can do on the calculator here, like 2 times 8 plus 5, and that gives us 21. So that becomes 21 over 8. And we're dividing by 1 times 6 plus 1 is 7 over 6. Now the next step for dividing fractions, there are 2 different methods that you could use. Typically most people use the keep, flip, change method. So 21 over 8 times 6 over 7, and then we would need to work that out as a fraction. Now, of course, we're going to show how we get to 2 1/2. So 21 times 6 is 126, and 8 times 7 is equal to 56. Now, if we want to really show that this is less than 2 1/2, we'd probably want to show exactly what this is now as a 2 and something number if it comes out as 2. It does come out as 2 because if we go up in 56s, and let's write out some 56s, 56 on the calculator plus 56 comes out as 112. So we know it fits in twice. We just want to know the remainder from 112 to 126, which I'll do on the calculator. 126 minus 112 comes out as 14. So it's 2 and 14 over 56. And then we would want to simplify that fraction. We can type it in on the calculator. 14 over 56. It comes out as 1/4. So that's 2 1/4. And 2 1/4 is less than 2 1/2. So I could write that using an inequality. I could say something like 2 1/4 is less than 2 1/2, or you could write it in words, completely up to you, but we've definitely shown that it's less than 2 1/2 here. We've shown all those steps in terms of how you would go about using the fraction and simplifying the fraction. We could add one extra little level here, which is dividing them both by 14, and that's just knowing sort of on the calculator, 14 divided by the 1 that we got on the top there. Of course, it's being divided by 14. You could do 56 divided by 14 on your calculator. You'll see that you also get 4. So there we go, a unique question. Obviously, fractions is usually a non-calculator based topic, but this show that variation makes it really good for a calculator style question. Question 24 is looking at some forming and solving equations. So it says here are 2 rectangles, all measurements are in centimetres. The area of rectangle A is equal to the area of rectangle B. Work out the perimeter of rectangle B. Well, because rectangle B has an algebraic length, in order to work out the perimeter, we actually need to know the value of x. And that's where this line, the area of A is equal to the area of B, comes into play. Because we can find the algebraic area of both, put an equal sign between them, and we'll have an equation to solve. Now, to work out the area of a rectangle, we do length times width. So if we do 4x times 2.5 for our first one, and you can do 4 times 2.5 on the calculator, we get the value 10x. The one on the right, the length and the width, we do have a 2x minus 3 there, so it will create a single bracket, 7 lots of 2x minus 3. We can expand that. We get 14x minus 21, and that is our area of the second rectangle. So now we can solve these. It doesn't matter which one you write on the left and the right, because this has a slightly larger x. I do prefer writing it on the left, but that's completely up to you. 14x minus 21 is equal to 10x. We want to subtract the smaller x from both sides, which is the 10x. That does leave us with 0 on the right, and that's absolutely fine. We get 4x minus 21 is equal to 0. I can then add 21 to the other side so that we can divide by 4. We get 4x is equal to 21, and then I can do 21 divided by 4 on my calculator. It does give me a decimal. We get x is equal to 5.25. So we have got a decimal value here for x, And that's fine, we're just going to use that, and now we're going to find the perimeter of the rectangle. So up here, x is equal to 5.25, so this length will be 2 times 5.25, which is 10.5, and then minus 3. So minus 3 from my answer, and it gives me the length, which is 7.5. So for my rectangle, to find the perimeter of this rectangle, I want to do the 7s and the 7.5s, top and bottom, and I want to add those all together. If I want to show some working out for this, I could do 7, add 7, add 7.5, add 7.5, and we'll work that out on the calculator. 7.5 plus 2 sevens, which is 14, and that gives us a total length of 29. Look back at the question, it does say all measurements are in centimetres, so that is 29 centimetres, and that is our final answer, 29 centimetres. And there we go, there is the perimeter after forming and solving an equation based off the area. Okay, so in this question, we do have a lot of words, but it says Amira is helping to organise a charity cycling event. The event takes place on several circular cycle tracks. Each track can accommodate a maximum of 15 cyclists at once, and there are 289 cyclists taking part in the event. Amira wants to use as few tracks as possible. Each circular track has we've got a lot of information going on. What can we work out straight away from the first part here before we read through the whole thing and then forget about what the actual question was talking about? So it says each track can accommodate a maximum of 15 cyclists at once. There are 289 cyclists. Well, straight away from that, we can work out how many tracks we're going to need. If we do 289 and divide by 15, we'll know how many tracks we've got. And then we can kind of almost eliminate that entire piece of information. 289 divided by 15, it comes out as 19.26 recurring. But we have to have a whole number of tracks here, so we will use 20 tracks. So we now know we're going to use 20 tracks. They're in the shape of a circle, and we can kind of forget about all of that information until we kind of need to track back and figure out about these 20 tracks. Each circular track has a diameter of 25 metres, and she needs to mark the outer edge with a special paint. And in addition, she's going to paint a 150 centimetre finish line on each track. So this is going to be to do with the circumference of a circle. They're going to race around this circular track, and we want to look at the diameter. So here, our formula for diameter, we have circumference is equal to pi times diameter, our formula for circumference, or you can use pi 2r or 2 pi r, which is just doubling the radius and timesing it by pi, the same as pi times diameter. So if the diameter of each track is 25 metres, we can do 25 times pi, which I'll do on the calculator, and 25 times pi is equal to 78.539. It does go on a little bit more than that, but we'll leave it at 78.539 for the moment. In addition to that, she's going to paint a 150 centimetre finish line. Now the distance that we've just worked out is in metres, so we could turn this into metres, so divide that by 100, and that gives us 1.5 metres, and that's the additional paint that she's going to need. So we can add 1.5 to our answer, so plus 1.5, and that gives us a total here for this one track of 80.03981634. Lots of decimals there. So that's the distance that she's going to have to use in terms of the paint for each track. It says the paint is sold in cans and each can covers 50 metres of line. How many cans of paint does Amira need? Well, for each track, she needs 80 metres worth of paint. And she's going to need that for 20 tracks. So if we take the 80.39 and times that by 20, as there are 20 tracks, that's going to give us the total amount of paint that she actually needs. So times it by 1020 is 1,600.796327. Now we can look at this final piece of information. Each can covers 50 metres of line. So we're going to need to divide this by 50, as each one covers 50. And if we divide by 50 on the calculator, it comes out as 32.01592654. Now, although that is just a tiny amount over 32, it is still more than 32. So we would use 32 plus the extra 1, so that would be 33. So there we go. We need 33 cans of paint to cover all of this. And there we go. We can put 33 cans if we want, but 33 cans would be our final answer. And there we go, 33. So there we go, just backtracking what we've done there, we worked out 289 divided by 15 was just over 19 tracks, so we used 20 tracks. They're in the shape of a circle, so we did circumference is equal to pi times diameter for the distance around that circle. We then got 25 times pi, which was 78, added the 1.5, which was the extra line for each track. There were 20 tracks, so times that by 20, and then each can covered 50 metres of line, so we divided by 50, it was just over 32, so we rounded it to 33. And there we go, there is a problem-solving question looking at the circumference of a circle. Question 26, it says Priya buys a bicycle, she gets a discount of 8% off the normal price and she pays £506 for the bicycle. Work out the normal price. So if she gets a discount of 8%, then she has paid 92%. Again, we can just do 100, take away 8, which leaves us with 92. So 92% was equal to £506. It's okay, there are lots of different methods you can use for this. I like to just divide down to 1%. And again, it's not the only method you can use. You can use the reverse multiplier, which is absolutely fine as well. I think this one here just looks a bit more visually sort of friendly. So 506 divided by 92, and that comes out as 5.5. And then we can get back to 100%, timesing by 100, all on the calculator. And there we go, that comes out as £550. So there was the original cost of the bicycle, £550. She got an 8% discount, and that reduced it down to 506. The next part of the question, it says Zane invests £7,200 in a savings account. The savings account pays compound interest at a rate of 3.1% for the first year, 1.9% for each extra year. Work out the value of Zane's investment at the end of 3 years. Well, these are both quite tricky decimal percentages. So if we want to work out the multiplier, which we'll use for this, we'll do 100 add 3.1. You can type that in on the calculator. 100 plus 3.1 is of course 103.1. And you can actually just press your percentage button, or you can divide it by 100 and it'll turn it into a multiplier for you. But that is 103.1%. which is equal to 1.031. Now there is a nice pattern with compound interest. It does tend to be that it's single digit percentages, so it's always normally 1.0 and then the percentage numbers written after that. So for this next one, if we follow the same pattern, it's 1.0 and then it's 19. So they are the multipliers that we'll use to increase by these percentages. So it starts with 7,200. We get 3.1% in the first year, so times 1.031, and then in the next year we get 1.019 or 1.9%, and we get that for an extra 2 years as it's 3 years. So I can either write down times another 1.019, or for the 2 years I can put a power of 2. So I can type this all in one go, 7,200 times 1.031 times 1.019, and I can put squared with that, as that's being done for 2 years, and that comes out as £7,707.96. It is actually 961375, but of course we can only go to the nearest penny, and we never normally round money up in this scenario. So £7,707.96, and there was using some compound interest. Our next question is looking at a probability tree. It says one weekend the Baines family is going to take part in a baking competition and a science quiz. The probability that the family will win the baking competition is 0.3. The probability the family will win the science quiz is 0.35. Complete the probability tree. So for each one of these missing probabilities, we will do 1 take away the number that's in the other branch. So 1 minus 0.3 leaves us with 0.7. We'll do the same for these other branches here. 1 take away 0.35 and 1, we can do them on the calculator, 1 take away 0.35 is 0.65. So 0.65 for our other one, and that's the same on the branch below as well, 0.65. And there we go, there is our completed probability tree. It says work out the probability that the Baines family will win both the baking competition and the science quiz. Quite a nice one here, because even if we did make a mistake on the tree, we have the win already given to us and the win already given to us here. So the branches that you go through, you just multiply the two decimals or fractions, if they were fractions, that you actually pass through on that particular journey. So 0.3 times 0.35, and we want to write that working out down, we'll write it down here, 0.3 times 0.35, and on the calculator it comes out as 0.105. Absolutely fine to leave your percentage, or leave it as a decimal rather than a percentage. Absolutely fine just to leave it as 0.105. Of course, you could convert it, you could times it by 100 and write it as a percentage, but typically when they are given to us in decimals, it's just fine. Just leave it as a decimal. You're not going to gain any extra marks for writing it in a different form. You could just potentially lose a mark if you accidentally do a difficult or the wrong conversion there, trying to write it in a more difficult way. Okay, so our last question here is looking at a simultaneous equation. So here with simultaneous equations, you can either look at the x coefficients or you can look at the y coefficients. Now I tend to always look at the y coefficients even though the x coefficients here are the same. Now that is because I've always used the rules, same signs subtract, different signs add. But you've got to be really careful, because if you use the x coefficients here, the x coefficients are both +3 and have the same signs. So here we would subtract these equations, and a lot of people accidentally make the mistake of adding them still, even because these symbols are different. So just be really, really careful. Make sure you stick to a method that you use. If you use the x coefficients here, absolutely fine. I'm going to times the top equation by 4 and make the y's the same, which gives me 12x plus 4y is equal to -16, and the bottom one I get 3x minus 4y is equal to 6. I'm then going to add these equations together, which gives me 15x, the middle two disappear, they cancel each other out, and -16 add 6, again just using the calculator, is equal to -10. Super careful here, because we are going to get a decimal or fractional answer, because when we divide by 15, which we have to divide by with 15x, -10 divided by 15 on the calculator comes out as -2/3. Now I would leave that as a fraction rather than -0.6 recurring. It's going to be much easier, particularly if I just leave that answer on my calculator screen, because the next step is to substitute that back into one of these equations. I'm going to go for the top one, 3 times -2/3, and I can type times 3 on my calculator, comes out as -2. So when I rewrite that equation, 3x is now -2 plus y is equal to -4. And if I'm trying to get from -2 to -4, y will have to be -2. And again, you can work that out by just adding 2 to both sides of the equation to get rid of this -2. So there we go, y is equal to -2. So we have two answers there. We've got an x and a y. I just want to write them both down. So x was equal to -2/3 and y was equal to -2. Double check that they were the answers, -2/3 and -2. And there we go. And there was our simultaneous equation. So there we go, that was our last question, and of course, like I mentioned at the start, this is just a practice paper where we are going over questions that haven't yet appeared. Of course, this is the second variation of a paper as well, so there are lots of different questions to make sure you look at. Do make sure you check out the first version, as that has other topics in there. For example, Venn diagrams was not in this paper, but it is in that paper. So just a little example there, just to make sure that you do check out all of those. Of course, make sure that you check over the checklist as well, and cover off any of those missing topics that you may or may not have revised up to this point. But otherwise, I hope that paper was useful. Another good collection of questions just to keep you checking in on all of these different topics. Do make sure you check in the description, because there are all the links there with all the different variations of questions within each of these topics as well, just to make sure that you are super happy with all of those different topics. But there we go, hopefully that was useful and helpful. That's the end of the video, and I will either see you for the next one or best of luck with your exams, and I hope they go really well for you. Please do let me know in the comments, and there we go.